welcome you all for this discussion on the topic design thinking approach and radar system. So you are going to discuss the design of radar using design thinking every stages. So radar system is used for object detection and tracking. So in this we are going to give a solution for high resolution radar system which is capable of detecting objects in a very long distance. So we are going to apply the principles and we are going to discuss one by one. So the final result should be applicable for air traffic management, defense, surveillance, etc. So consider these application and give a solution for the radar systems.
So first is empathy part. We might know the condition of air traffic controllers and disaster, which is applicable in all weather conditions. Where it is in a false conditions, it cannot be applicable. So we are using affordable and giving the importance to a low power consumption and dependable, and it is a real example of data visualization.
Okay, next, in the define stage, the main goal is to state the problem that we need to solve after understanding the user needs. Here, the radar system are used in many important areas such as air trafficking and defense vehicles and disaster monitoring. In these areas, radar must detect and track the objects clearly and on time. And in the real life conditions, radar will not work in a clean environment. They may face a reflection of object or intervention of any other factors or some other distractions. So, which leads to a wrong reading or false alarms or missed targets, and which affect the safety and the decision making. Here the main problem is to design a radar system that is accurate, reliable and stable even when the power or bandwidth or the hardware resource is limited. So it should work continuously without any failure and also being cost effective and energy efficient. This is how the problem statement is defined.
So next to that, I'm going to do the ideal path. So several radar design options are explored theoretically, like pulse radar, FMCW, and monostatic and bistatic radar applications. So first, pulse radar, which is used for long range detection, and second, FMCW, which is used for short range detection and high resolution applications, and digital signal technique, which is used for detection of the target. And these are some ideas that evaluated based on cost and power efficiency, range resolution.
Now I am going to tell about the prototype. In this, we are going to discuss about the conceptual design of this problem statement, in which we have the four units. First is the transmitter unit, in which the signal is created and transmitted to the receiving side. We create the radio signals and transmitted based on the frequency it needed. Then the second part is antenna, in which antenna receives and sends, do the both jobs. First one is directional antenna, which focus only on the one direction. Another type is beam width antenna, which covers the large area of the area. Then third part is receiving unit, which receives the message and signals from the antenna and processes it within it. Then is a signal processing unit, which gets the signal from the receiving unit and it removes its noise and decodes its information.
The next part is testing. During the testing, the evaluations of the system performed during the maximum bandwidth detections and access the radar and velocity through the accurate target and tracking, and measures the signal to the noise and to accurate the noisy environment and to measure it, and detects the false alarm probability to reduce the incorrect detections. And the radar systems are used to work in the real-time fashions and verified stability and reliability to ensure the clarified confirmations of all the performance.
Okay.
So we have all discussed the design thinking approaches on the radar system. So because it includes several units like transmitter, antenna, receiver, and also signal processing. So we need to give a clear problem statement for designing the high efficient antenna. So we have taken the clear problem statement and we have given several ideas for designing the radar systems. Thank you all.
Thank you.